An increasingly common use case of Spark is dealing with streaming data. So to this point in the course, we've talked about analyzing offline data sets in a batch manner. So we have this pile of data and we want to analyze it or process it somehow. But in the real world, data never stops coming in, right? So this is where Spark streaming comes in. It allows you to ingest streams of data in real time. For example, you might have a fleet of servers generating log information getting funneled into your Spark cluster, being analyzed as it comes in. Maybe you're transforming that data and storing it somewhere else in some other database. Maybe you're aggregating it over time and looking for things you want to be alerted on as they happen. Either way, streaming is a very important use case in the business world these days, so let's dive in and see how Spark streaming can be used to analyze data as it's created and take action on it as need be. So in this section, we'll introduce you to Spark streaming. This is a very common use case for Apache Spark these days, where we're dealing with streaming sources of data and not just transforming a bunch of data all at once in a batch process, but continually monitoring incoming data and doing something to it in real time as it's received. So a common example of that would be processing log data coming in from a website or a server, or maybe a whole fleet of servers that power a website. That data never stops coming in, right? So there's no really simple set of log files that you can point to and say, hey, go analyze this chunk of log data. It's always coming in. There's always new information being gathered all the time. And maybe you want to aggregate and analyze that at some given interval or window of information, right? Maybe you want to set up some sort of an alarm where if you're seeing a bunch of errors on your website, something gets notified automatically, right? So instead of just waiting for a nightly analysis of that data, we're analyzing that data continually as it comes in and doing something with it. That data doesn't have to come from a raw file. It can come from some port that's receiving TCP data. It can come from Amazon's Kinesis service. It can come from an HDFS or some distributed file system. It can come from Kafka. It can come from Flume and all sorts of other data sources too. So Spark streaming can integrate with a bunch of different systems, not just text files, and analyze that data as it comes in. And it might not just be about analyzing and aggregating data. It might be about transforming it and just sending it somewhere else too. Maybe all Spark streaming is doing in your case is taking incoming log data, extracting the information you care about it, structuring that data, and then storing it in a database somewhere. That's a perfectly valid use case for Spark streaming as well. And a nice thing about Spark streaming is that it has a checkpointing feature. So if your stream does go down, if your cluster goes down for some reason, it has an easy way to automatically pick up from where it left off automatically. So that's a nice feature for sure. So let's start talking about the old DStream API for Spark streaming. Basically, Spark streaming has a storied history, if you will. The original interface for it was called DStreams, and it was based on the old RDD interface. And because it was based on RDDs, it was centered around what we call micro batches. So it just dealt with these chunks of data that were represented as RDDs, and it processed those little chunks all together. So technically speaking, it wasn't true streaming. It wasn't actually operating on data on a field or row by row basis. It was chunking things up into what we call micro batches. Now in the real world, that's usually not really a problem. If you have a latency of a few seconds as opposed to immediate processing, for most applications, that doesn't actually matter. But that was one of the main things that caused them to move away from this interface over time. I'm going to cover it just for historical reasons here, but we will go on to the more modern structured streaming API after this. Anyway, here's an example of what DStreaming might look like. So you would set up a streaming context as opposed to a Spark context, and that seconds one there means that it's going to process things 1 second at a time. So you'll have these micro batches that contain 1 second worth of new data that we're going to process as part of our script. We can then say stream.socket text stream, and that's going to tell it to listen to port 8888 for text data being sent in on that TCP port. And then all it's going to do is filter those incoming lines for lines that contain the word error. And if it sees a line that contains the word error, it will print it out. Once you've set that up, you just have to call stream.start to actually kick it off, and stream.await termination to wait for someone to stop it. So it's a little bit magical, a little bit weird to wrap your head around this paradigm, right? So you have to remember that we're not processing a single chunk of data. This directed acyclic graph that we're constructing here to process this data and take in data and filter it out and print it out if it passes that filter, this is going to be applied repeatedly for every 1 second worth of data that's received automatically. We don't have to write a loop somewhere that says keep doing this every 1 second repeatedly. Spark streaming does that for you. So The syntax here may seem a little bit of strange and magical at first because it kind of just works on the stream. You don't have to think about that bit of it too much, but it does work. So at a high level, that's how it works. Some gotchas. So remember, your RDDs are only going to contain one little chunk of incoming data. Now what you can do is windowed operations. With a windowed operation, you can combine results from multiple batches over some sliding time window automatically. So there are functions like window, or reduce by window, or reduce by key and window. So those window functions allow you to do a reduction over some time going back in the past. So I could say, go back for the past minute, go back for the past hour, go back for the past day, whatever it is, and reduce my information down based on that window of information. So that window does not need to correspond to your batch size. That can be much larger, and it will automatically keep track of those RDD results, those micro batches, and apply your operation over that window of time that you've defined. So it automatically keeps that information around so you can analyze it as you go. Also, something worth talking about is update state by key. This allows you to maintain a state that spans across many batches as time goes on. So if you need to keep track of some sort of running state as you process this information across windows or across batches, you can do that with update state by key. A good example of that would be running some sort of a count or an ongoing count of some event over time since you started the script. So if you do need to keep track of something as the script runs as a whole, as opposed to over some window of time, update state by key lets you do that. So let's dive into a simple example here. We're going to run a Spark streaming script that just monitors live tweets from Twitter, and we will keep track of the most popular hashtags as we receive new tweets. And to do this, we first need to set up a Twitter developer account. Now, some people have trouble doing this. It depends what country you're in, how you fill out the form, what kind of a mood Twitter is in, quite honestly. So I'm not sure you really want to go through this yourself. You can, if you want to, just go to apps.twitter.com and apply for a developer account there if you do want to follow along. Honestly, I think you should just watch me do this next activity because, as I said, DStreams are kind of dated now. If you're just taking this class for the purpose of getting a certification, I can promise you it's not going to be in the certification exam. So you might just want to watch me do this following activity instead of following along. But if you do, you can. Just go to apps.twitter.com, sign up for a developer account, and then you can create the API keys and access key tokens that you need to actually query Twitter and pipe that into Spark Streaming. So to store that information, your credentials, you'll need to create a twitter.txt file, and I'll show you where that is when we walk through it. It's just going to have a name of your consumer key and access token information on each line, and our driver script will read that in and use that to authenticate with Twitter. Our overall strategy here, once we have that Twitter stream established, we're just going to extract the messages themselves. There's a bunch of metadata that Twitter gives you as well, but we're going to create a twitterutils.createStream that's going to be using a third-party library that I've included with the course to actually connect Twitter and make it look like a DStream. And then we'll call tweets.map to extract the text field on that by calling status.getText. So at this point, we'll have a new RDD, a micro batch, if you will, that contains nothing but the status messages from each tweet that's received. So for example, maybe one tweet says, vote for hashtag Bodie McBoatface. And someone might say, vote for I like big boats and I cannot lie. And no, vote for hashtag what iceberg. And someone else might say, what, are you crazy? It's hashtag Bodie McBoatface all the way. And if you're wondering what the heck I'm talking about here, this was a meme several years ago. Basically, I forget what Navy it was, but they ran an online contest to let the internet name their new ship. And of course, that was a horrible idea. The winner, of course, was Bodie McBoatface, which they did not use. But I think they stuck it on some like little submarine or something that was on the ship or something. Anyway, in this example, we're trying to keep track of the most popular hashtags, right? So in this case, we would have hashtag Bodie McBoatface showing up as the number one result with 2 appearances, and hashtag what iceberg would be the second result with 1 appearance. So we've established our stream of status messages. Next, we can use flatmap to split that out into its individual words. So by calling flatmap on that statuses micro batch, we will then blow that out into a bigger RDD that has a row for every single word that appears. So for example, the message vote for hashtag Bodie McBoatface would just be broken up into 3 separate rows, vote for hashtag Bodie McBoatface. And since all we care about are the hashtags, that's the only thing we're measuring, we can then call filter to filter out any rows that do not begin with the hashtag symbol. So that will reduce things down to just the hashtags that are showing up. And at that point, we can do our old trick from way back in like section 1 or section 2, whatever it was, where we can convert those to an RDD of key value pairs, where the key is the actual hashtag and the value is the number 1. That will allow us to later do a reduce operation to count them all up, which is what's going on here. And we're going to do that over a sliding window to make things interesting. So the reduce operation will add up all of those ones together and give us a total count for how many times that hashtag appears. But we're using a stream here, so we're not going to say reduce by key. We have to say over what period of time. And to do that, we'll say reduce by key and window to perform that reduce operation over a given window and slide interval. So we're going to say reduce by key and window, basically adding everything up. And when you pass this in, you need to explicitly give it a function for adding and removing elements as it goes. That's what's going on here in this syntax here. And we're going to say that we're going to apply this over a 300-second window. That's the past 5 minutes with a 1-second slide. So we're going to slide our window over every 1 second and look at the past 5 minutes worth of data. So that what this is going to do is recompute that reduction, that count of hashtags every second going back for 5 minutes. And we should get a result that looks like that if that was our actual sample data. So finally, we just need to sort and output the results. We will call transform to sort that RDD based on the second field, which is the count, and print them out. And that should pretty much be it. So let's go and see it in action. Note that we do have some extra libraries that we're using, some third-party libraries. I'll show you how that's set up. And yeah, let's just dive into the code and see if it works. Could be interesting.